last couple sections were about waves, and we were looking at waves on a string, or at least that's what we're doing now. This one is going to be about reflection and inversion. Essentially what we're doing is saying we have this wave that's on a string. We have a pulse of a wave on a string, and it's going to move its way down toward the end of it. What happens when it gets to the end? So let me pull up a simulation for this one. This is a simulation that gives us a string. I can adjust, or I can move this wrench up and down, but I can also just turn it to pulse, and then that'll move this thing up and down for me. It's going to be a little smoother. I turn the damping down to 0, and I want to look first at what happens with no end. So the string just goes out a window. When I do this and I pulse this once, that wave just goes, and it goes away forever, right? There's no reason for it to bounce back. It just keeps moving. Turn this pulse width down. There we go. We'll go a little bit sharper like that. Alright, but now I want to look at what happens when we do have something going on at the end. When I put a fixed end, that means this green ball on the end is not able to move up and down versus a loose end where it can slide up and down. With a fixed end, this one's held in place, so when I send this pulse out, it starts to go toward the end. Everywhere where this pulse is moving, this string wants to move up, but here at the end, it's not able to. So we're going to see what happens. It jumps up and tries to get there, but it can't really get there. So let's try that again. With a fixed end, normal. As I get a little closer, this wants to move up, the next one wants to go up here, then this one wants to go up here. But we start to run into trouble because of this fixed end, and where I had this nice triangular pulse all the way down, now I've got something that's starting to warp. So what happens? Physics 1, we talked about momentum. This wave that was up here is coming down. Usually that momentum has just been transferred to the next spot, but now it can't be. So it's going to just kind of slam straight through and catch on the other side, and then travels back. So what I had on the end, I reflected, my wave started moving backwards. I also inverted, my pulse was at the bottom. Over here I am about to hit this left side. This left end is fixed in place. So what I expect is that, again, this thing's going to reflect, it's going to move back to the right. I turn my damping down to 0, so this wave's going to keep going back and forth. It's always going to reflect at the end. Because this end is fixed, it's going to invert again, so I expect to see a wave pulse on top moving across. And I do. Every time it reaches the end, because the ends are fixed, this thing inverts. Now let's see what happens when the end is loose. I can get the same start. There we go, we'll get real close to it. Okay, this wants to move up, and because there's a ring here, because it's a loose end, this actually is able to move up. So let's see. This spot moves up. Then it'll start to move back down, because that's what it does, and so we're going to reflect again, because we're always going to reflect, but this time, because it was able to move up, it's not going to have to slam all the way down through the equilibrium spot. It can reflect without inverting. The other side is fixed, so here I'm going to get a reflection and an inversion. Here I'm going to get a reflection without an inversion. So this wave moves back and forth, and on the left side it always inverts, and on the right side it doesn't invert. So I want to take that information and summarize it. It's a fixed end, versus loose end versus no end. We've got reflection and we've got inversion. So, yes, fixed end reflects. Yes, loose end reflects. No. When there's no end, there's no reflection. Inversion, a fixed end inverts, a loose end does not, and no end doesn't even reflect, so it might be more accurate to say does not apply. That's reflection and inversion for a wave on a string.